Hello, my name is Quinn Hyman. I am a data analyst on the IPUMS International Project. I work in both creating geographic variables for all microdata samples that we disseminate through IPUMS International. And I also work in creating the shapefiles, which are geographic boundary files that are used in conjunction with census microdata. In this demonstration, I'll be going through viewing, editing, and preparing shapefiles that match census microdata figures. I will be doing so in ArcPro, which is the flagship program from Esri. And the goal of this demonstration is to show how shapefiles corresponding to later census years can be opened and edited to therefore match boundaries from earlier census years. And the whole idea in this demonstration is also just to give a brief idea of what can be done in ArcGIS. So the first step is opening the program itself. And this is what the base program looks like, opened with nothing in it. The left-hand side will be showing all layers, which are the individual files added to the map. And on the right-hand side, we can see the catalog pane, which is the data sources for all of these different files. As my colleague Shula pointed out in her presentation, we will be using a GADM file in this presentation, which I have labeled in this folder here. Underneath this folder, we can see all of the options for Senegal when one downloads the shapefile from GADM. Each underscore corresponds to the different levels of geography available for Senegal. And in this presentation, we'll be looking at the second, so we will go with the underscore number 2. When I click and drag, the shapefile for Senegal level 2 is added to the map, and we can then see the individual boundaries for Senegal. Now, one of the most important features of the shapefile itself is what is known as the attribute table. And the attribute table is where all information about these different polygons is stored. The way to access the attribute table is right-clicking on the shapefile in the content pane and navigating to this tab here labeled attribute table. And when we open it, default setting is to send it to the bottom of the map. And this is not ideal for viewing shapefiles as it compresses everything in the top. So what can be done is to drag it outside to then view the shapefile along with the attribute table. And in this attribute table, we can see all of the data associated with each individual polygon. And highlighting a row in the attribute table will highlight the corresponding polygon as well in the shapefile itself, giving a detailed view of all information associated with each polygon. And as Shula also pointed out in her presentation, it includes some of the most important attributes, which are labels, as we see here, the label for the first geographic level. And in this column, a label for the second geographic level. And lastly, the code column, which provides geographic codes for each individual polygon. And what's great about GADM is that since this is corresponding to the latest census year of Senegal, which is 2013, these codes match exactly to the codes listed in the census microdata file. And because of that, I know that the number of polygons in this shapefile corresponds exactly to the number of units in the second geographic level of Senegal. Now, GADM was chosen for this example because of its detailed nature and because they provide census data at the latest year available. Another great resource, however, is SALB, or the second administrative level boundaries provided by the United Nations. And these boundaries are validated by each individual country to be accurate. However, SALB in this case did not provide as detailed boundaries as GADM, which is why this one was chosen. But one of the benefits of SALB is they provide boundaries corresponding to specific years, census years, or specific years of history. So the previous census of Senegal was carried out in 2002. And SALB provides census boundaries that were validated by the government of Senegal to correspond to their census boundaries. So if we overlap these two, we now have 2 years of census data, one on top of the other. Now, this represents the best case scenario for moving backwards through history in editing shapefiles. There are many ways to produce geographic boundary files that correspond to different years of history. One way is to move forward in time, which theoretically would make moving from less detailed to more detailed, or moving backwards through time, which is moving from more detailed to less detailed. That is the direction we're going to go in this demonstration, as we find that it is best to go from greater detail to less detail to preserve the most amount of specificity found in that source shapefile. So in this scenario, we can adjust the color and symbology of the individual census shapefiles to view boundaries and how they have changed from year to year. So clicking on this little box below SALB shapefile, we open up the symbology pane that can show different symbologies. For this demonstration, we would like no color, but the boundaries to have color. So we would select this first one. And the default color it assigns is black, but that's not always easy to see if we have dark colors on top of dark colors. So we will then change the color to red. And the GADM file underneath, we will do the same thing. However, we will change this color to blue. Now here we can see a better idea of how the boundaries have shifted coming from one census year to another. In some regions of the country, you can see there are very few boundary changes, whereas in others, there have been quite a few changes. And one of the areas I would like to highlight is in this area right here, where boundaries between these units have shifted quite a bit, with a lot of splits and a lot of boundaries changing location. Now, this also represents the best case scenario in that both censuses have shapefiles that are readily available and ready to use, but oftentimes this is not the case. And you will have to instead rely on maps that have been published in census figures. But this actually can be used in the ArcPro program. So images can be brought into the map and boundary changes made using specific maps. So we're going to assume that SALB did not have a map for 2002, and we're now going to adjust the 2013 shapefile we have to match boundaries on level 2. So what we have here are images saved from the 2002 Census Atlas that was provided by the Statistics Organization of Senegal. So we are going to bring in this image, which corresponds to the second level of geography from Senegal in 2002, and match it to this shapefile. Now, when I bring it into the map, I'm going to get a notification that there is an unknown coordinate system. This is because an image does not have any inherent geography data attached to it, and we will have to make that ourselves. So if we zoom out from our map, we can then see the image is much, much larger than how it should be, because again, the image does not have any geographic data attached to it. To fix this, we will have to perform what is called georeferencing, which then assigns the image its appropriate size. So while the image is selected, we will then go to the imagery tab and open up the georeference panel. What we now can do are add what are known as control points. These points will match the image to the shapefile itself and act as anchors, controlling the image's size. So in ArcGIS Pro, it is very helpful in that it presents exactly the order that the control point needs to be assigned in that the source be assigned first, followed by the target. And the source is this image, and the target is our shapefile. So an ideal start is to find a geographic point that is well noticeable and will not be confused with other points, possibly leading to an incorrect reference. So I would like to start at this point right here, as it is prominent and does not surround any other possible points I could be confused with. So I will left click and then find the corresponding point on my shapefile and have them match. Now what happens is that the image is brought under the shapefile, but because we only have one point, the shapefile is still smaller than the image itself. So we will have to add multiple points to make sure that the size is correct. So I'll find another point that is isolated, selected from the image, and bring it into the shapefile. I now have an image that is much, much easier to work with and is much closer to the boundaries that it should have. However, it is still a bit misaligned, so we can add further control points to fix that. So we will add another one in the southern part of the country. And we'll add one more in the northern part. So now I have an image that is fully georeferenced and sitting comfortably underneath my shapefile. So now I can take a closer look at the image that was published in the census figures of Senegal and compare it with the boundaries that I now have that correspond to 2013. And what in the same area of the country that I highlighted underneath those two shapefiles, I can see the same set of boundary changes that occurred. So now that I know these changes have occurred, the next step is bringing these changes to be a part of this shapefile. So now I will have to edit this shapefile. And to do that, I will simply select the shapefile, come to the Edit tab on the top of the screen. And now I'm provided with all of these tools that are used to edit shapefiles. Now, the only tools that are necessary in this brief introduction to opening and editing shapefiles are these two here, merging and splitting. These will cover most of the changes that are found in geography between census years. Merging brings two polygons together, and splitting creates two polygons or more from one single. And this area of the country does a good job of highlighting both of these scenarios. So the first one I'm going to demonstrate is a merge. So the first step is to select the merge tool, and now I am free to select the two polygons that need to be merged. Now, when I see in this area right here is that this polygon in 2002 is a single polygon, whereas in 2013, it is multiple. So the first step would be to select both polygons that need to be merged, and I get a panel that opens up on the right-hand side of the screen, showing that I'm modifying two features in merging. Now, the helpful tool is also that it shows which polygon will quote unquote be preserved, is in that which polygon will retain its data in the attribute table and which one will lose its data. Now, what's helpful about the image underneath is that it provides a label. So I know that COSAS is the one that needs to be preserved. And so when I have that selected under the preserve menu, if I had the other one selected, it would show a different label, but I want to have the default one selected. And then I will hit merge. And now I am left with a single polygon. And that is almost where I need to be. But if you notice, there are other parts of this polygon that don't quite line up with the boundaries that it needs to. And in that case, we can see there is this boundary that does not quite line up with where it needs to be. It is another part of this polygon was attached to another one in between census years, and it now needs to be removed to make sure the boundaries align. So that requires a split. So I will then go to the split tool on the menu and select the polygon again. And this time I am brought up with tools along the bottom of the screen. These are all tools that are used to make splits, but in the most basic sense, the default tool is the best one to use because it allows you to make different vertices along the line that you need to split, or different points along the line. So with the polygon selected and with the split tool in use, I can simply select a point along the boundary and then click along the line below in the image, following it along, then create a new boundary. Now, once I reach the other boundary where this would end, I can simply double click. And now two different polygons have been made. Now this covers almost all boundary shifts you will see in the most basic sense, but this also only controls the geographic shape and size of polygons. If we remember back in the beginning of this demonstration, the attribute table, that will still retain the information from the earlier censuses. That will also have to be changed with each additional merge or split that is done. So if I go to this polygon, again, opening the attribute table in the same method I did before, I can see that its code is now copied from other polygons that it was made from, and it retains the same label. And it may not want to, and I may not want it to retain this label if it is not corresponding to this polygon. So it can be edited simply by double-clicking and can then be added to as anyone would edit a text file, a Excel file, anything. And any code could also be changed in the same manner. And that is the conclusion of this demonstration in creating census shapefiles and opening them in ArcPro. And hopefully you're now more aware of how different boundaries are assigned going backwards through time to create different census years. Thank you.